So let's work on the second half of this lesson. What we did yesterday was we learned how to take our values, so in a range from -23 to 238, and calculate what that should be in terms of our range for our values. We have to include one extra value for 0 at that case. And we're going to go from 238 to 23, so those two numbers are included, and we get our total range of 262. Our lowest value, of course, is -23. And just to verify that, we can go through and look at our math here. We have 0 to 1, which is technically, if we want to make that inclusive, it would be including up to 0.999 ... Multiply that by our range, 262. This becomes 0. This becomes 261.999. Then subtract our 23. This becomes -23. This becomes, again, this is all inclusive now, 238. And then cast it as an int, and we go from -23 to 238 like we wanted to. So what does this look like in code? Well, if we go back to our code example, we can see that our range would be 262, and our subtraction will be -23. So if we write that out, our random function would be math.random, but we're going to multiply that by our range, which is 262. And we're going to subtract from that 23, and we also want to take that whole thing, throw it in parentheses, because we want to cast this whole thing as an int. Now we can either store that in a variable, let's say int my num, or we can print it out to the screen. That would be entirely up to us. Just to be sure, we'll throw in some extra parentheses in here. We want this to occur first. Java should do it anyway, but just to be clear, we'll throw in our parentheses. So if you want to know more about the different math functions that there are in Java, you can go to what's called the Java docs. So in this case, I have it linked to Java 7. It could be Java 8. We could just change the URL at the top to include Java 8 if we wanted to. But this goes through and lists all the different possible classes that we would possibly be interested in, and all the different packages. We want the Java math package, so we'll take a look at that. And we can see everything that's included into that. When we do our calculation. So you can look at any one of these and kind of figure out what's going inside that package in terms of libraries, and get any extra functions that you might need. So in the future, think about some of the problems I give you. If you might need an alternate solution, you might want to look here to see if you can find out what that alternate solution might be. So that would be the docs.oracle.com, Java SE, and you might want to do Java 8. So just change that to an 8, and you can see it'll jump right ahead to Java 8. See, there we go. And we can get everything in Java 8. So when we take a look at the random Java doc, we can see that it returns a double value with a positive sign, greater than or equal to 0 and less than 1. This information will be provided to you on the AP exam, but just this, none of those math calculations that we talked about. So essentially, any of the functions that you need for the AP exam will be given to you, but you'll be getting them in a Java doc style form. So we can see that when this method is first called, it creates a single new pseudo-random number. We talked about that in class as not really being random, as if we had used a new expression. And then the new pseudo-random generator is used by, therefore, for all calls to this method and is used nowhere else. So if you do it more than once, then you'll get another set. But if you run the program, you might, more than once, you might get the same set. So if many threads need to generate a pseudo-random numbers at a great rate, it may reduce the connection time for each thread to have its own pseudo-random number generator. So again, that randomness isn't truly random, and it kind of depends upon the computer speed and how many people are accessing, or how many parts of your program are accessing that random number generator. There's also another method called random with a capital R that is different than the math random class, and we'll have to take a look at that in the future. So one last thing in terms of our calculations. We had talked about this briefly in one of the activities, but I want to make sure it's really clear. When we have int equals x is 9 and int y equals 3, and we do a system.out.println of a string and then a plus and then those two numbers, what we get is the 9 and the 3 are concatenated up together. So they're not added. We want 11, but that's not what happens. They're just rammed together because active memory is set up as a string, not set up as int. And what we really want to happen is we want it to do these calculations first and then concat the string. To make that happen, we're going to have to follow PEMDAS. So PEMDAS says do parentheses first. So we're going to take our 9 and our 3, put them in parentheses, then Java will do this part first and do the calculation with active memory being ints because it's doing integer addition. And then it's going to treat this plus sign as a concat. So this plus sign gets treated as addition. This plus sign gets treated as concating. So when we put the string together, it does the 12 first because it's 9 plus 3. And then does the concat where it takes the 12 and puts it with the string. So plus sign changes its meaning depending upon the context. That's called polymorphism. And Java will interpret what is meant to be done based upon the way you structure the statement. In essence, concatenation means to add two strings. So it really is a form of addition, which is odd because you guys probably aren't used to doing addition with strings. You're used to doing addition with numbers, but not with letters. It's kind of odd. But in terms of what Java thinks, it's really the same type of thing. Java's in somehow combining information, whether it's concatenating it or adding it, is dependent upon the context. It cannot add the word high to the word 7, number 7, so it really has to do something different. And then that something different is a concat, but it can't jump back and forth. It makes the most logical interpretation, that is that once it runs into a plus sign that's concat, everything's concat, because why concat the 7 with the high and not the 90? It doesn't make sense not to. And it has to read this in order from left to right. So if we switch this order and did 7 plus 90 plus high, and did 7 plus 90 plus high, the result would be 97 high, actually without the space. So in that case, it does the addition first because that's what came first. It's order of operations. And one final math operator. This is not included on the AP exam, but it's a useful math operator to know. It's logarithms. This will give you the log base 10 of any value that you put inside these parentheses. So I could do log base 10 of 50, and the result would be what power is 10 risen to give you 50. Now the reason that's useful is I challenged you to come up with a solution that would avoid doing integer division if you want to get the ones, tens, and hundreds position. So I had to come up with a solution for that challenge. And my solution involved doing some logarithms and some powers, and it was kind of tough to do. The other thing that I had to throw in here was this 0.000001, because in some instances, I ended up with a weird answer, which we're going to talk about in the future in the next lesson. So you might want to think about, what is Java doing that I need to do this, that I have to add in this extra piece here? Why is I'm getting odd answers? And you notice that in some of the other lessons when we did our calculations, is that sometimes we got answers that just weren't quite right. Maybe there was a 0.00004 at the end of it, or there's some type of other garbage involved that just didn't make any sense. So is Java really just doing math wrong? Can we trust Java to do math correctly? What's going on here? We're going to investigate that in the next lesson. So if you've completed the fast start activity and watched the video, you should now have access to the exit ticket. This is a little note about the scanner class and how the scanner class really is an object and requires the new constructor, whereas the math class is also an object but doesn't require the new constructor. We talked about that in the previous lesson as being a static class, and we're going to have to talk a lot more about that. That's not quite as simple as we're leaving it here. We have to do more work on that. But I want you to do the exit ticket. And once you've completed the exit ticket, you can work on this program, and I'll let you work on in class the next session. I'll also let you work on this program. It's called Guess the Number. You're to write a program that uses the scanner class to get an integer. It has to be an integer from the user, and then prints out a random int from 1 to 100. Sample output looks like this. What is your favorite number? They might type in 23, and you'll say 23 is a nice number. My favorite number is 78, and the 78 is randomly generated between 1 and 100. Write the program in Dr. Java and submit the code in the written submission box, but also upload the .java file so I can run it. So I want the code in the submission box, but I also want the .java file. When you're done, you will get a second exit ticket. So I want you to complete that second exit ticket after you complete the Guess the Number. And again, wait until I give you some feedback on the first exit ticket and the Guess the Number before you dive into the second exit ticket. That's all for today. See you next time.